This lesson is about magnets and magnetic forces, and by the end of this lesson you should be able to explain what's meant by the poles of a magnet, plot the magnetic field around a bar magnet, and also describe how magnetic materials can be induced to become magnetic. So before we start, have a little go at these questions. They should be from Key Stage 3, so just see what you can remember. So hopefully you realise that the four magnetic materials are iron, cobalt, nickel and steel. Of course steel is magnetic because it contains iron, because it's just iron and carbon. The same poles repel and the opposite poles attract. That's the laws of attraction and repulsion for a magnet. And you may also have done this in Key Stage 3 where you made an electromagnet using an iron nail, and all you do is wrap a coil of wire, loads of coils of wires around, and when a current is running through those wires it induces a magnet, and that's an electromagnet. Now you can increase the strength of that magnet by increasing the number of coils or increasing the voltage or current. So if you've got a magnet and a compass in home, this is one of the things that you can have a go at doing, but you do know how, you must be able to describe this in your GCSE as to how you can use a plotting compass to look at the magnetic fields. So when you're using a plotting compass around a magnet, you place the compass near the top of the north side of the compass, and what you're looking at is where the compass is pointing, and there you just make a dot. You then move the compass so that it's lined up with that dot. You then place the next dot, and you continue this all the way around. And you do this on both sides and then draw in the line. So once you've completed your diagram, you should have something that looks a little bit like this. And what you need to notice, and this is really important, that you put the arrows in. The magnetic field runs from the north all the way round to the south, and that's on both sides of the magnet. And where the closer together that the field lines are, the more strong the magnet is. So they show how the strength of the magnet is. The closer together, the stronger they are. So we can see that the magnet is weaker on the sides but much stronger at the poles. So if we were to place two magnets together with attraction or repulsion, I'd like you to just pause the video here and have a little go and think about what those field lines would look like when you had two north poles together, or a north pole and a south pole together. So if we're looking at repelling, we would come up with a pattern that looks like this. So you can see where the arrows are both coming out of the north, but they're repelling each other. So if we put a north and a south together, they would be attracting. And remember, this would just look like this. So you'd have coming out of the north going into the south, and it would just be straight lines across between the two. Now magnetic induction is when we have a magnetic material which is inside of a magnetic field from a permanent magnet. Now this is something again you can try at home. Get a magnet and see how many paper clips you can line up. And the more paper clips you can line up, the stronger that magnet. So this is also a good way to test a magnet to see how strong the magnetic field is. When the paper clip is away from the magnetic field, we have this idea of the domain theory, and the domain theory just means that there's domains within a magnetic material which outside of the magnetic field will actually be randomly arranged. When it's within a magnetic field, those domains line up, and that's what causes the paperclip to experience magnetic induction, and that induction will stay until the paperclip is outside of the magnetic field. So it's important to remember that the paperclip is magnetic only when it's in the magnetic field, As soon as it's removed from the magnetic field, it will lose its magnetism. So it's important to realise that because compasses always point to the North Pole, it means that it's evidence that the Earth has a magnetic field. But what you should also realise is if the north end of a compass is pointing to the North Pole, then actually, if we were to think of it as a bar magnet, the North Pole would actually be the south pole of the bar magnet. So hopefully you'll now be able to explain what's meant by the poles of a magnet. You'll also be able to know how you can plot a magnetic field around a bar magnet using a plotting compass, and also describe how magnetic materials become magnetic through induction.